What do you think, Jim?
Sound good.
All righty. So my name's Craig Stevenson. I'm with the Oris Group. Welcome everybody to the second event for the Passive House Bootcamp. This event is put on by the Passive House Western PA chapter, as you can see on the screen. We are a chapter of the North American Passive House Network, which has an affiliation with the Passive House Institute. Last week, we did a 101 to Passive House, and we did an introduction for both FIAS and PHI. We do intend on running that again throughout the year. We'll probably run it at least once or twice more. Jim and I have been tasked with putting on this boot camp, and we're moderating the boot camp through the next 5 sessions at least, and we're hoping to do that throughout the rest of the year. Jim, you want to introduce yourself for us?
Howdy, folks. My name is Jim Bischoff. I'm an architect. I work at Moss Architects here in Pittsburgh. But in this aspect, I'm representing Passive House Western Pennsylvania. Usually, if you're getting a newsletter or now seeing on Instagram, it's all coming from me. So if you need something to reach out, you can reach out through that email address right there, or now you can attempt to find us on Instagram. Not much there yet because we just started, but yeah, I'm a CPHD. I think we had a slide here, Craig, about maybe you were going to talk about, yeah. So we recently became a chapter, and what that means is you can become a member now. So if you become a member of NAPHN, you automatically become a member of Passive House Western Pennsylvania if you live in the greater area of Western Pennsylvania. You get some benefits for that. If you go to the website, you can learn all those things. But also that means you can be a little more involved locally with Passive House Western Pennsylvania. We're still going to do free events like this. We're also going to have some things that are for the members. So if you were on the Passive House 101 in May, or if you've attended one of our Passive House 101s in the past, you'll have seen there's 5 key principles of Passive House. There's insulation, continuous insulation, I should say, thermal bridge-free connections and construction, high-performance windows and doors, air tightness, and mechanical heating or mechanical ventilation with high efficiency, heat recovery. So this week we're going to start with the first one, continuous insulation, and every 2 weeks we're going to do the remaining of those topics. And then after those topics are done, we're going to get on to something else, something we've either figured out folks are interested in learning, or we just decide, we have any questions, here's the next thing we'll talk about. They're going to be at 4 o'clock every 2 weeks. If you're not on our schedule yet or on our mailing list, let me know. You get these messages. If you're attending this, hopefully you found that
Hey,
out.
Jim. So I just wanted to mention for everybody here on the event that this boot camp is intended to be a hands-on learning experience. So, we want this to be a dialogue. Jim and I are going to moderate it. So we'll do the introduction about the boot camp in general. We have 2 experts from Rockwell with us. They'll introduce themselves here in a second. And then they're going to have a very short presentation. It's going to last about 15 minutes. If you have a question, raise your hand. You can come off mic and say, excuse me, come in. We're informal. We want this to be a dialogue. After their short 15-minute presentation, then we want to pepper them with as many hard questions as we can. The theme today, and Rob's laughing because he knows it's coming, but he can handle it. The theme today is really built around the enclosure, the thermal envelope. If we get into some air barrier transitions, that's okay for this conversation. It's all the same. If we talk about fenestration, windows and doors, that's okay too. So don't be afraid to ask questions. We want this to be a dialogue, and we hope this turns into just a rich conversation.
Yeah, at the same time, this is meant to be sort of an introduction, right? So this is not a replacement for a full CPHD course. This is an introduction, so if you were interested in this, you would learn and get a little more excited about it, and then hopefully move on and take this full CPHD course and learn that giant wad of information that is Passive House. So I think that's the end of our little short intro.
Well, the next presentation we have is built around thermal bridge-free connections.
Sure.
We have someone who is a Passive House certifier, so they've been highly trained, not just for CPHD, but for also certification. And they'll be coming in and showing us some hydrothermal and some thermal bridge analysis. And we'll roll our sleeves up, we'll look at some assemblies, we'll bring it in, and we'll play with it. And that's intended to be sort of like a learning exercise, like hopefully today will be. So with that said, today is about the continuous insulation and the thermal barrier. And I will give screen back to Rob. Rob, you and Mike, please introduce yourselves. There it is. All right, I'm stopping screen. You got it.
Okay, let me make sure I get the right screen up. There we go. And share. All right, my name is Robert Blunt. I'm the architectural manager for Rockwool in New England. I've been for a time here, almost a year, making some trips out to Pennsylvania to cover Pittsburgh. And that's where I met Jim and Craig. I'm joined by my colleague, Michael McGuire, who is now the current architectural manager for the Mid-Atlantic. So he is the rep for this region. We're here today to talk to you about understanding advanced wall system design around continuous insulation. So we'll touch upon not only the continuous insulation aspect of things, but also air tightness and avoiding thermal bridges. I'm going to jump right into it so we can try and stay to the 15 minutes. Then you can pepper me with questions afterwards. This is a presentation that is an excerpt from our full CEU that we developed with John Straub from RDH Building Science. So I'm kind of made it skeletal, trying to touch upon the points that I think are most important for this audience. So when we look at building enclosure and control functions, we look back first. Hopefully we're all learning from our mistakes, even the ones that are from 1,000 years ago. So older buildings, we know old stack stone masonry. We've got one building system that theoretically assumes all the functions we want, our thermal control to some small degree, air control, water control, and vapor control. Of course, now the way that we build is a bit different, right? We've got a ferroconcrete core. We have a substructure of LGMF that holds that sheathing, and then ultimately all of these control functions that we've separated out, sometimes in one product, sometimes in a bunch. But where we like to start on this subject is with the perfect wall. So for those who aren't familiar, the perfect wall is a concept that most credit to Wagdianis from Thornton Tomasetti. The things you'll notice about it that are important are that in our layer of substructure, we don't have any insulation. That makes it a very simple design. It makes it very safe. We don't worry about moisture buildup in that inner wall cavity. Because we don't have any insulation in there, it means that we can use a perfect barrier for our water control layer, right? So we put our control layers in here in what we think is the level of importance. So of course, we've got to keep the building dry first. So that water control layer can be, as I said, a perfect barrier, much like glass or metal panel, zero permeability. If we're doing that water control layer well, if we're paying attention to the details where we keeping continuity in that control layer, where we hit windows, where we hit penetrations, we get good continuity, then we should be okay for air control. If we're not doing that air control layer well, the rest of these don't matter, right? We're going to lose it through vapor drive. We're going to lose all that heat and vapor out, if we're not airtight, we're not thermally tight. And ergo, the importance of air tightness in passive house, right? We want to hit that 0.4 CFM for our blower door test. And then we look at thermal control. So what I found over the years, I've worked as a consultant, I've worked as a project manager, mostly doing design assist, with all of these products that we use on the exterior substrate, is that they really rely on adhesion, right? Whether we're talking about peel and sticks or liquid applied or the sealant that we use to keep continuity, all of that stuff works better when it's kept at a more moderate temperature, doesn't see high spikes or low spikes, and also sees minimized exposure to moisture. So that thermal control layer, aside from giving us our value, also extends the lifespan of these other products. And then in terms of vapor permeability, we have a perfect barrier back here, but we want an insulation layer that allows for any incidental moisture that's going to occur on the face of that weather barrier to wick away or to be pushed away in the form of vapor and out of the wall system. So why are we doing thermal control? Well, from a passive house perspective, we want, it's about not only thermal comfort, but also air quality and also keeping our spaces quiet. So as we're doing those things well with our thermal barrier, hopefully we're also keeping surfaces at a moderate temperature. We don't want exceptionally hot or cold surfaces, especially on the when it comes to our metal studs, right? If we have cold studs and hot moist air, that means we possibly have condensation in our wall sections, and this black icky stuff up here, or the degradation of the build itself, right? We see studs corroding or rotting depending on the material. But ultimately, we're doing all that well. We should be saving energy and reducing heat flow. When we look at thermal controls and what are the most important aspects of it, we see the movement of energy through our wall sections in 3 different ways. Conduction is the biggest one, right? Thermal bridging. So those studs, our structural steel, our slab edges, all of the more, the more dense the material, typically, the bigger a bridge of heat it is. Then we look at convection, right? Our air tightness. So second law of thermodynamics, heat's always moving to cold, wet's always moving to dry. When it does, it's taking energy along with it. And then thirdly, radiation, right? So line of sight gain, not as much a topic for this conversation, but certainly something we think about when we design. How do we face our buildings? Do we use passive shading measures? Are we using low emissivity coating? Or maybe we're not. Maybe we want to benefit from that solar gain with a truly passive design in some instance. So then we look at rated R value, or our overall thermal resistance terminology. So rated R value, that's this nominal theoretical static number set at 75 degrees. It doesn't do much for us except tell us what this material is doing at one temperature at one time. We put that nominal value into use. We put it in a wall section. And then we realize, okay, we're derating this material for what's around it. How much thermal bridging is affecting that thermal barrier? And then ultimately what we want to look at is our total R value. So that effective R value, also taking into account all the other pieces and parts of the wall, our air films, our air spaces, the gypboard. So that aggregate number is what we want to look at, our total R value. When we look at that aggregate number and we look at where we want to put our nominal R value, this is the nickname for the presentation that Dr. Straub gave it, stuff it or wrap it. Do we stuff it in the inner wall cavity, or do we wrap the building in that thermal barrier? The spoiler alert here is that the answer is wrap it, not stuff it. But it's not always that simple either. Oftentimes we're designing in urban environments. We have limited space. On the outside, right, a lot line and a setback, and on the inside, a client wants every bit of programming space they can get out of their dollar. So we've got some decisions to make. The first thing we look at is thermal bridging. We look at some infrared imagery from building in New York 6, maybe 7 code cycles ago. Clearly no continuous insulation. We can see all that loss in the red and the yellow, right? The studs, the window frames, which clearly are not thermally improved. Our relieving angle on that masonry column, all of those are big culprits for loss. As we moved along, maybe now 3 code cycles ago, we're looking at the use of some continuous insulation, the basics from ASHRAE, right? Probably an R10 on the outside, the use of a non-continuous attachment system, so clips instead of rails, or instead of continuous Z-shapes. We do see, we can still see the trace of that slab edge conducting heat. We can see the surface penetrations, which aren't thermally broken. And then, of course, for some reason, on the left side of this elevation, we see some continuous Zs, and that shows it takes that heat straight through the studs, right out through the Zs. This is where we want to live, right? When we see our thermal imagery, that's calming blue color. This is a passive house build in Brussels, Belgium, pretty early adoption. Windows haven't quite caught up with the wall technology. This is actually an EFIS building. I don't typically promote or applaud EFIS as a solution, but it's really the first, it's the first iteration of an effective continuous insulation solution. Of course, it worked a little better in the EU than it did here, at least in terms of details, and we can talk about the nuts and bolts of that later on. So when we look at thermal bridging and what its real effect is, if we take our very typical commercial build, right, 16 on center LGMF studs, 2x6 wall, we can fit a R23 bat product in there. But if we derate it, what we actually have, our effective R value there is an R10. So not highly effective to use that thermal barrier in that inner wall cavity. Even with a residential build with wood construction, we still see up to 25% loss. And then we start to take account for the rest of the structure, right? All of this steel, we know that we can't get to the numbers, whether we're talking about basic code or let alone passive house levels, by only using that thermal barrier inside. If we look specifically at the studs, we see this is a page stolen directly from Dr. Schwab's book on high performance buildings, but we look at a temperature plot across the profile of a stud, and by the time we get halfway through the stud, we're definitely below the dew point. By the time we get to the outside, we're almost to the freezing mark. So clearly, we have to use some continuous insulation to make this work. When we look at the impact of using that continuous insulation, if we use as a starting point the best we could do by filling the wall full of insulation, and then start to add continuous insulation on the outside, what we find is that as we buy continuous insulation, we actually get more than we buy, because we're improving the performance of the insulation on the inner part of the wall. So if we're buying R5, we're actually getting an effective R6. If we're buying R10, we're getting 11.2. And that curve keeps on going, and it really doesn't flatten out until we're well into passive house values in terms of insulation in the R50, R60 range. So the message here is that effective R value is the performance of the entire assembly, not just the material. As we start to look at getting to higher insulation levels and look at some different solutions, we've got a number of things to consider when we're using exterior insulation. What is its permeability? If we're talking about a typical passive house detail with a double stud wall and a lot of dense packed cellulose, we need to be aware of what's happening with moisture there. If we're doing adaptive retrofits or adaptive reuses and we're insulating formerly uninsulated masonry walls, what's happening with that moisture, and at what point is, especially in the winter, is that moisture getting trapped in those scenarios and potentially becoming destructive? And then what we typically see for a highly insulated wall is this split insulation scenario. So we've got some rules of thumb on ratios of effective R value inside and out, as well as definitely a need to use a vapor permeable membrane between those two assemblies. Other things to consider specific to insulation are that R value isn't constant, right? As I said, it's established at 75 degrees, but temperature changes, R value typically goes up with the exception of a couple of materials. Also aged R value, there is thermal drift. So some materials R value changes over time. And then of course, depending on what we select for material, fire resistance is a big component. When we're talking about the exterior insulation, that continuous insulation, we're usually talking about stone wool, polyisocyanurate, or extruded polystyrene. In some cases, also looking at Gutex or something like that, but these are the big three that we see in commercial builds. And what we find is that materials that are fibrous insulation, they get their R value from trapping air. Rock wool does, Gutex does, other mineral fibers do, but thermoplastics get a piece of their R value from blowing agents in the manufacturing process. And over time, those blowing agents either off gas or they phase change. And when they do, their efficacy changes. So ultimately, we all kind of live in the same effective R value boat. And this is just a little bit of excerpted warranty language from thermoplastic manufacturers and thermoset manufacturers on what to expect in the long term with those materials. I'm going to let Michael speak to the roofing aspect of this, because it's a little bit different. It's a little bit different animal, and also more in his wheelhouse in terms of expertise.
Thanks, Robert. Robert's already kind of set the table on the performance of foam plastics versus that of those products that trap air. As commissioning started to come in play, the National Roofing Contractors Association just took it upon themselves to test foam plastic, specifically polyisocyanurate foam, but rather than at just 75 degrees mean Fahrenheit, they tested it using ASTM C518 that measures the thermal performance at 25, 40, 75, and 110. This particular chart shows the diagram that basically was occurring with the foam plastics as temperatures changed. Keep in mind, at 75 degrees mean Fahrenheit, if the average R value is 5.6 to 5.7 per inch, that basically 4 samples had were already below their published R values. Next. If I take this chart and I graph it, what you're going to see is basically the sweet spot for foam plastic at 75 degrees, providing an R value of 5.6 to 5.7. Stone wool for the roof is around 3.8. For the walls, more like 4.3. But as temperature changes, you'll notice those lines basically cross. And at 25 degrees, stone wool actually outperforms isocyanate foam. So for passive house construction, when you're looking at long-term performance, it obviously makes more sense to use something that traps air versus a foam plastic. Next.
Oops.
Yeah.
Sorry.
Just as a note, this is a busy screen. I just want to make this real simple. This is the aging process, and this is what's happened over time with foam plastics from 1995 up to 2012. With the changes in the blowing agents being used, you can see, depending on the color of the line that was basically shown in the time frame, how radically different the performance is. In fact, the green lines from 1995 to 96, they were using chlorofluorocarbons, and obviously you can see they perform pretty well with colder temperatures. Today, we're using recycled pentane, and those blue lines you can see as the temperature drops, the insulation thermal value drifts off. Next.
So as we look at, okay, it's not just thermal barrier, as we start adding more and more thermal barrier, we need to think of what the rest of the assembly looks like. So for passive house, that typically looks like a drain rain screen assembly. So we know that we need good continuous plane of drainage to control water, to pay close attention to those penetrations and openings where we have transitions. That also contributes to good air tightness. We also want to allow for maximum drying potential of that wall in case of heavy weather events, in case of accidental introduction of water. So we want, ideally, vapor permeable products for that thermal barrier. We also, as we're providing that continuous insulation and good continuous air barrier, we should be doing a good job of controlling condensation problems and decreasing our energy consumption. The one thing that I want to throw out there, and we can talk about this in a little more detail in Q&A, is that if we have a split insulation scenario, we want to make sure that that weather-resistant barrier behind the insulation is something that's vapor permeable. And we can talk a little bit more in detail about that as we move on. So we'll real quickly look at choosing a cladding attachment system. There's no sense in putting a ton of insulation on your building if you choose cladding attachment systems that are going to allow a ton of thermal bridging, right? So we'll look at masonry real quickly. We see a transition from the use of carbon steel brick ties to stainless steel brick ties. They're about half as conductive as carbon steel, so 100% more efficient. Those continuous shelf angles, which are good for 50% aggregate loss, not just localized loss, have been replaced with the typical shelf angle standoff or a thermally broken structural element. When we look at all these different cladding options, these are kind of the top row here, the old school continuous rails, and even down to aluminum clip and rail systems are relatively inefficient. We're going to look at these three thermally broken and screw-through systems as the more efficient options. What we need to know about those as options is if we're using a clip and rail system of any kind, the material that we use with it, the insulation material, wants to be semi-rigid so that it can conform around all those details of hardware, or spray foam, not as typical in this marketplace, but every once in a while I see spray foam on the outside of a building. And then if we're looking at a screw-through insulation, so the only thing going through that insulation is the fasteners for a girt system, we need to make sure that that material is rigid enough to handle the, has enough compressive strength to handle the load that we're applying to it. And this is a real basic rundown of what each of those assemblies looks like in terms of efficiency. And we see a big spread in all these because of the amount of clips that you might have to use to accommodate the load. So we look at clip and rail systems. This one's from Knight. It's their MFI system. So somewhere between 60 and 90% efficiency. And as I said before, the difference in efficiency revolves around how many of these clips are we using. The more metal we pass through that insulative barrier, the less efficient it is. So heavier loads are going to be less efficient. We also put in a relative cost factor, and then more dollars means more dollars, and more hammers means easier to build. We look at fiberglass clip and rail systems. This one happens to be Cascadia. There are a few others out there. You probably know Cascadia in the passive house world because oftentimes their windows are looked at along with these clips because they're they don't use aluminum, they use these pultrusions, and they have much higher R values than typical fenestration. But what we see is 70 to 95% efficiency, about the same relative cost and constructability as typical clips. And they do have a pretty, I think, a pretty interesting tool on their website where you can do a clip calculator that allows you to turn the knobs of your R value, your cladding weight, and the amount of clips that it's going to take to get you there, which then again also informs the levels of efficiency. And then when we look at screw-through systems, we have a couple different options. So a very light cladding, a residential type application, fiber cement plank type system, we can go right through the plank, right through 2 inches of rigid insulation, or right into the substrate. Anything heavier than 5 pounds a square foot wants to utilize a vertical girt. That vertical girt basically, in conjunction with those fasteners, becomes a ladder truss. So that's how it's able to assume higher loads. So we can load up to 15 pounds a square foot. And anything above that probably wants to look at using a rigid shear block. For my money, I'd probably go back to a clip and rail system rather than try to incorporate a rigid shear block in a screw-through system. But these are the levels of efficiency that we see. So up to 95%, the 95% end of things is informed by the amount of fasteners. We do see thermal conductivity through those fasteners because they're pretty robust, anywhere between 3/16 and 5/16 of an inch. But we also see a relative cost drop because we've eliminated a layer of hardware. And in terms of constructability, it's really not a heck of a lot different than what we see with the typical clip and rail systems. And then a real basic metric, what is our backup that we're attaching to? Are we going to wood? We're doing, mid-rise wood, typical steel stud backup, or unitizing and going to concrete and our block backup. And then what's the weight of the system that we'd like to attach, and some best practices on that. And that's a little over our 15 minutes, but I did my best. I like to extend myself as a resource to anybody out there. My history in the enclosure space is that I spent about 8 years consulting with Gordon Smith Corporation in New York City, a lot of curtain wall, a lot of fenestration testing, to the destructive point, a lot of running fenestration products and cladding products into testing to enter the marketplace. And also spent a lot of time as a project manager doing design assist, so working with folks like yourselves to build a better mousetrap. And I'll let Michael speak for himself, but Mike is kind of the roofing guru at Rockwool that's come over to the wall side for the Mid-Atlantic.
Thanks, Robert. As Robert said it eloquently, I've taken over pretty much the Pittsburgh market as well as the entire state of Pennsylvania. I have probably 27 years in the commercial roofing industry working for major manufacturers. And while I'm new to the walls, I'm not new to construction. So I'm a resource for the building envelope. If I can be of any help, I will be more than happy to assist. If I don't know the answer, I'll tell you I don't know, but I will find the answer and get back to you. So having said that, I'm going to turn it back over to Craig.
Thanks, guys. Rob and Mike, really appreciate the presentation. And, I can tell everyone here that it took a lot. Please keep the screen, Rob, for now, because I have a feeling we're going to go back into a few of the slides. We got a lot of questions.
Yeah,
so,
I'm switching over to the bigger deck because it's going to have more resources.
Great. So I want to just make a quick announcement to anyone who might be interested. Rob and Mike have been into the Pittsburgh area a number of times. They've done presentations a lot for our Passive House network. If your organization is looking for a great lunch and learn, they got a long deck, a long version of what you just saw. So please put out a request. These guys, if they're in town, will be more than happy to come through, do a lunch and learn, give you your CEU credits for it. And there's no better presentation than this. And that's why we're excited to have them here with us today. So if you have questions, please throw them into the chat, or feel free to come off mic and ask your questions. I'd like you guys to come off camera if you can. Might be nice just to see everybody as we go through the Q&A. This whole boot camp is intended to be a Q&A. So ask those difficult questions. Any projects you're on, you're trying to solve some problems with an assembly, ask. And to that point, Rob, can you take a second and explain the resource that Rockwell provides industry relative to assembly analysis? I think that's a really interesting resource, and this audience would probably be interested in hearing about that.
Yeah, absolutely. So Rockwell has a whole building science department, and they're folks that are master's level and above, building scientists, really some of the smartest folks in the industry. And we offer a suite of technical services that range from hydrothermal analysis, basic dew point, effective R values, 3D R value modeling, if you're willing to provide that kind of time and information. And it's non-proprietary, it's complementary. So, SD, DD stages, you want to look at what's your wall section, how well does it perform both thermally and from a moisture perspective. You can do comparative analysis between our material and foam or Gutex and lamb's wool, whatever it is. These folks are into the science of it. They want to see the best wall assembly that you can build. So they're a great resource, and it's usually relatively quick. They always say it takes us a week to do a model, but more often than not, when I send them information, it's a couple of days. And as I said, it's a great resource. Once you're passing the point of no return on what your wall assembly is going to look like in terms of profile, this is where this is where the rubber hits the road. And it's, even if you're using it as a check with consultants that you're working with, or even against your own, internal modeling. I know a lot of firms, especially the bigger ones, are doing a lot of that stuff internally as well. But it's a resource. Even internally, it's sometimes hard to get a hold of.
It is a
Robert,
great
if I could
resource
just
for a
expand
quick
on that.
check. Go ahead, Mike. I'm sorry.
That's all right. Just for 2 seconds. The one thing to keep in mind, it typically takes anywhere from 3 to 5 days to turn a report around. But once the report's built, it's very easy to modify. I'm working on a project with the federal government. I think we're on version 5, reiteration with the design professional to come up with the solution to some of the things that are being seen within their wall assembly. So they'll not only take the time to do the report. If you need a conference call, we bring them in. We put them on the same similar vehicle that we're using here, and we basically address the questions that are within and how this was all developed. So it's very thorough and excellent to use, and it doesn't cost a dime. So feel free to use it. I can help you with that.
Yeah, it is a great resource. I wanted to share it with the audience. I thought that they would certainly want to take advantage of it. If nothing else, it's a great check into their assembly to make sure that it is durable and they're not risking any thermal bridge or durability issues with their walls. If there's any questions, please come off mic, raise your hand, come into the chat, however you like to ask your question. Roberto, you're up.
Quick question about, thanks for the presentation. That was really, really informative. My question is around sustainability and product performance in terms of, are there any environmental product declarations or ingredient disclosures, any red list declarations, the big kind of debate?
The big three, sure. So we have EPDs on everything, third-party EPDs. They've been newly released to reflect the product specifics. There used to be a little more general, kind of like the industry-wide EPDs are, like from NEMA. We are red list free and also Green Guard Gold declare. So we check most every box when it comes to sustainability. I often get questions about also carbon embodiment, especially from some portions of the passive house community, because there's occasion, depending on the project motivations, sometimes there's a desire to do encapsulate some carbon in the design too. And we kind of sit in the middle of the road from that aspect, right? We're not a cellulose product, but overall, I'd say as compared with most of the other products that are in the industry, we're in a pretty good spot, and also are working towards circularity efforts. So by the time the things that you're putting into the wall today, in terms of stone wool need to be, by the time that building gets turned around, we plan to have a circularity. It's already happening in Europe. It's a little, we're a little behind here in the US, but we plan to have a circularity program where that material can be recycled.
Very helpful. If there's any other questions, please keep coming off. Rob, you mentioned the vapor permeability on the one, and you said you wanted to come back to it. I'd like to invite you to go back to that slide and talk about that.
So for me, I'm just going to get up to the split wall assembly slide. By the way, I'm more than happy to, I know that some of you might have seen my presentation at Passive House Western PA in November. I'm more than happy to share this, the full deck as a PDF, just as a reference as well. So if we look at split insulation scenarios, which are a typical solution for, especially in urban environments, what we know is that we want to use a vapor permeable barrier between the exterior and the interior whites of insulation. And also that it's important that that exterior insulation be vapor permeable, because we don't want to see water get trapped back here. Also, rule of thumb for a split insulation scenario is we want to see an effective R value that's roughly half and half as a conservative number. The more you can put on the outside, the better off you are, but you certainly don't want to cross that 50-50 barrier for effective R value. So if we look at it in a kind of more code specific application, if we have R10 on the outside, which is what ASHRAE calls out for a prescriptive insulation scenario, usually calls for R10 on the outside, and depending on your climate zone, R13, R15, R19 on the inside. So we know that whatever that inner number is going to be derated for studs, and let's say it's R13, it's going to end up being R6, and the effective R value on the outside is R10, so we're okay. But those are some kind of basic rules of thumb in terms of what we're doing with split installation scenarios. And then most times, especially for a passive house build, we're looking at an interior vapor barrier too, typically a smart membrane, right? A Sega Pro or Intello or CertainTeed's membrane, one of those smart membranes that allows for moisture to pass out of the wall back into the conditioned space, but won't allow moisture to go into and accumulate in the wall.
Thank you. That was helpful. So we're hearing a lot of, we have a lot of projects going on in Pittsburgh. It's a real hotbed for passive house, and we've got a few interfit projects starting up. Can you talk about your thoughts around inside out versus outside in, given the choice?
Yeah, that's it's very much situationally dependent. The last time I was actually in Pittsburgh, I was looking at it was a University of Pitt Medical Center building where they did an adaptive reuse of all things, a Toys R Us building. So they used to use these foam core poured block scenarios to make those buildings. And of course, it's not enough insulation so, this is this case here, right? We're gonna put insulation on the inside of a masonry wall. So what happens, of course, is we're stopping energy from flowing out through that masonry, and we're also stopping the energy from driving the moisture out of there. So we need to look at very specifically with modeling, making sure that we're stopping the vapor there on the inside of that wall, so that we're not allowing diffusion to put moisture into that block or brick in the worst case scenario, if we're talking about a historic building, and then freezing when we get to that part of the season, and which can contribute to the early demise of the building. I've spent a lot of time on this particular detail due to some projects here, and I also live in a 250-year-old house that's got 3 whites of brick, and I'm trying to make it as close to passive house as I can. And that's a very tricky one, and definitely bears some modeling. But the typical solution looks like a smart membrane, your interfit insulation, typically a stud wall out in front of it, and then another vapor barrier, air barrier on the inside of the block.
Are there any other questions?
I see Felipe's got his hand up.
Felipe, come off mic, please. There you go.
Thanks. Can you hear me now?
We can.
Yep.
Hi everybody. I'm working on a project that is also a retrofit. It's going to be an inside-out retrofit, most likely due to the character of the building. The question I really have is the original house, which is a big house, used to be a convent. It had built-in boxes under the windows with radiators, radiant heat. So they're basically built in a brick wall that has like a 3/4 of this brick is a thickness of the brick wall. But then I would say at least 2/4 of that is this box that it's basically hollow now because it's basically a non-usable radiator that now I need to fill. And when it comes to retrofit passive house, I know I will put a continuous layer insulation in the back. But what to do with that box, with that hollow box, it will be a good question to know. Of course, I don't want to create any extra thermal bridging. Ideally, it should be just all brick, but it's not. So is it better to go for just rigid insulation there, fill it out somehow, or is it better just maybe just fill it again with brick masonry, just do a one whole flat material or flat layer? What do you guys think about kind of things?
I'd have to see the detail, but for me, I wouldn't want to lose the opportunity to introduce some more capacity for installation. If it's localized, there can be some issues with that. You want to be more or less consistent, but it might be a good candidate for sending to RBS, especially for a 3D model, so that they can look at what's going on around it.
RBS is your building science folks.
Yeah, Rockwell Building Science. I can help you with that, Felipe.
Okay. I'll be happy to take a look.
We can send you out there's a real basic form that they look for that just describes the project and your projected relative humidity and pressures and all that good stuff, which sounds pretty straightforward for this.
This is something that we most likely I won't be having the capacity to test the brick or anything like that. I know it's just brick wall right now, but it's something that I would prefer to take a look at it in advance, because I know eventually I'm going to have to deal with that. Right now I'm in the process of just making sure the building is watertight, and there's just we just replaced the roof. It has a new roof, so
yeah, it sounds like an ideal candidate for some modeling.
Yeah, definitely. That's something that I know I want to do in the short term, an energy model of the building, and make sure that walk section works with that. There's only one wall basically that has that condition, and this is, imagine like typical double hung size window, probably 36 inches wide. But then there's a hole right below, and every window on this side of the building that used to have a radiator. And that thing is just sits inside of the wall, and those things are disconnected. We need to still remove them, but yeah, what to do with that hole will be a good case for RBS. I definitely will get in touch. Thanks.
So Felipe, I just want to jump in real quick. So when Rob's talking about modeling, I just want to make sure it's clear for the audience. There is whole building energy modeling. That would be PHWPA and WPA passive. That is looking at the whole energy profile, performance of the building for heating demand, cooling demand, things like that. What Rob is talking about is doing subcomponent modeling, and that's looking at the thermal bridge analysis or the hydrothermal analysis for wall durability. That's a service that RBS provides. They don't do the whole building energy modeling. They do the subcomponent modeling to analyze envelope optimization and durability. And Rob, correct me if I'm wrong, but there are no fees for RBS working with people, correct? You guys do that as a service?
Absolutely. It's just a value add. We actually will do whole building models. You've got to be willing to put in the time and provide all the correct information.
I wasn't aware of that. That's good to know.
It's I don't think a lot of people are. I think, as I said, most people engage at an SD/DD stage where they're trying to figure out what exactly to do with the assembly. But if you've already established a relationship with those guys, Anton Habelian, who is the head of RBS, and Vincent Chu, who is second in command there, they love to get their teeth into that kind of stuff. And especially something like what Felipe is talking about, where it's kind of a real out-of-the-box application, or retrofits can be tough. And, you know, that's the kind of stuff, they live for that stuff.
Yeah, we're used to just doing quick what ifs when we're doing changes of materials and looking at different things. And RBS is a really great resource for that, for the subcomponent, but I wasn't aware you guys did whole building.
Yep.
Excellent.
I saw David raise his hand.
Yeah, Dave Burton.
Hey there. I had a question for you, Rob. I'm working on it's actually my house. Looking on a passive house certification here in Western PA, and we're looking to do a split insulation design. I heard you describe an additional barrier, a vapor permeable barrier on the interior, and I had not seen that in a split insulation design. And I heard you mention it, and I'm curious if you could describe kind of the purpose of having a vapor permeable barrier in mid wall, but also you said to have another one on the interior wall. Why would you do that?
So it's in order to minimize the potential for moisture getting into the interior width of insulation through diffusion. And it also, in a lot of cases, it's easier to control that, it's easier to control air inboard than it is on that or, you know, it's a kind of a belt and suspender scenario, but oftentimes it's easier to detail that air barrier on the inside than it is at that, you know, at the outside of the, you know, between those whites of insulation. If you look at, there is a standard set of Rockwool Passive House details, or a Passive House guide, which gives you a number of different resources.
Mike, can you put that in the link? I'm sorry.
Yep, I'm doing it right now.
Thanks, Rob.
Thanks. I just hadn't seen that, the value in that yet. And I'm not sure if it's climate specific as to why you would use that I know that we're in a very interesting part of the country here in Western PA where we have we're nearly right at that 50% mark when it comes to heating season and cooling season, which is actually one of the reasons we're looking to do split insulation with half of our insulation on the exterior. I'm still not sure I understand the science behind it. Thanks for explaining it, but I'd definitely like to see some numbers and follow up on that.
Yeah, absolutely.
We usually go to about the top of the hour, so we got time for a few more questions if anyone wants to jump in.
Hi, Sonia here.
Hi, Sonia.
Hi, how are you? Thank you for the presentation. That was very informative. Actually, I'm working on a retrofit project as well, and I'm dealing with an existing assembly made of concrete block, a couple inch of rigid insulation, and then brick veneer with an airspace behind it. And I'm looking at adding outboard insulation without removing the brick veneer. Do you have any experience with such a retrofit challenge where you're trying to deal with an existing brick veneer cladding and trying to avoid the demolition and leaving the material in place?
So you want to leave your exterior brick veneer and add a rigid board insulation on top of it, and then a type of cladding product on top of that?
Yes.
It's certainly, in terms of the building science, not too big a deal. We do, you know, I'm sure you're going to do a little bit of probe work to find out what's going on with the weather resistant barrier behind the brick. If it's a quite old structure, then probably it's non-existent and maybe it's not a big deal. Then it really comes down to the engineering, right? Like, can you use that brick as a substrate to anchor your new cladding system into? Is the engineering going to bear that out? Do you have, you know, if there's a envelope consultant involved, they're typically going to look at that kind of stuff and say, all right, we need to do some pull-out tests on the brick, et cetera. But from a air tightness and insulation perspective, as long as the engineering checks out, I'd say it's probably a pretty straightforward procedure. You just treat the old brick like it was a masonry substrate. But again, the weight of the cladding and the rest of those things certainly need to be weighed in on by a structural.
So you don't think we can secure directly to the existing concrete block, because we're talking about 4-inch brick veneer, 2-inch ventilated space, and 2-inch insulation. We're only talking about 8-inch.
So are you saying you want to go through the brick and open up some holes and attach all the way into the block?
Yeah.
That's certainly an option. Again, certainly a structural engineer way in. I've seen cladding setups like that before. I did a lot of retrofit work when I was in New York. A number of reclads, both curtain wall and kind of more traditional masonry and traditional buildings as well. That's very much up to the structural, and I guarantee you they're going to want to do a lot of invasive testing, a lot of probes, a lot of they want to see what's going on inside that wall cavity.
Okay. Do you have any example projects I can refer to and search the lessons learned from those retrofit projects?
A lot of that happened when I was on the consulting side of things, so I definitely left a lot of that information behind due to my employer then. But I'd be happy to put my eyes on it and maybe refer you to the right folks to help you out.
Sonia, I can also add that we have a PHWPA Western PA chapter that's putting on this event, and there's a lot of experts in our eco community. If you can't find the right resources, shoot us an email and we'll find someone that can help you out.
Thank you.
You're welcome. We have a couple questions on chat. So Paul asked a question. Paul, do you want to come off mic, or would you like me to read the question? So I'll read the question. With regard to the split insulation profile with vapor permeable membranes at the midpoint and at the interior, this sounds like a detail specific to the use of rock wool / mineral wool as the exterior insulation. And that's sort of what Sonia was asking too. I mean, you were talking about structural concerns relative to doing that sort of retrofit, but what kind of thermal concerns would you have relative to gaps, when you try to insulate the outside of a brick and it might not be completely flat and plain?
Certainly you want to make sure that your thermal barrier is tight and flat to the substrate. Using any type of semi-rigid material will allow those inconsistencies in your substrate to be kind of taken up by that softer material on the backside. So certainly you're not going to use a rigid foam. You could use a spray foam product if you're completely covering something up. There are a number of different products you could use, but our product does lend itself well to that particular application. I did just post the link for the Passive House guide in the chat. We also are about to release a retrofit guide that probably addresses a lot of this information, and as soon as I get my hands on it, I'd be happy to share it with you.
Thanks, Rob. Gary, can you come off mic and ask your question?
Sure, actually it was somewhat related. Yeah, I'm working on a retrofit, and we've got basically a 3-wife mass masonry wall. It's a 100-year-old building. Our basis for design was a traditional EIFS system with rigid foam board. But in order to meet the spec of the EIFS manufacturer, we basically had to do a leveling coat on the masonry first, and then so we have a nice smooth surface to attach the board.
Right.
Using a rock wool product, you just mentioned you can absorb some of the bumps and lumps in the substrate. Are you then able to attach the EIFS to your board, or does that telegraph through? And are you really only able to do that if you have a cladding system? So I know you can do stucco on rock wool. I've seen it in a couple of different manufacturers, and and I think you showed it to us one time when you were here. I think you were in a couple months ago. Yeah. So I guess the question is, can can you still cover the lumps and bumps and not telegraph that through to the stucco?
It's tricky. That's definitely, you know, who's your installer is a piece of it. But, you know, if you're trying to get get back to a flat plane, you know, that kind of, that begs a system that allows for some adjustability, whether that's clips or a series of girts and shims, what have you. But if you're going there, you can certainly, go do girts over a rigid board and make the adjustment there, and then put, after that, whether you need a concrete board to do a traditional stucco on, or whether you need another material just to apply the mesh and do a soft coat.
Well, I'm not married to the stucco either. I mean, in fact, what sort of raised my eyes to it as I was talking about a different part of the building where we're actually building a new wall, and was talking to the folks from one of the clip systems, and they said, hey, by the way, if you're doing rock wool already, if you're using rock wool instead of foam, our clip system with like a cement board panel can be pretty competitive to stucco. So
yep, and that very much depends on the assembly, but I've seen it a number of times. I've helped to detail it a couple of different times, both retrofit and new construction. So it does work. How far out are you on the project?
It's just out to bid right now.
Okay, so you're close.
Yeah.
We are close to a full stone wool based EFIS system.
Okay.
It's already being used in Europe and Canada, but it hasn't been through ICCS testing here.
Okay.
And I know of a handful of jobs that have done it here in the US.
We'd probably be, we'd be looking at, depending on how the project gets funded, prior to the shutdown, they wanted to have everything done by the end of the year. But at this point, I think what we're trying to do is get it dried in, and we are doing an interior air barrier. So we're trying to get it dried in this year, and it might not, the exterior work might not happen till next year. So
I would suggest that you reach out to whoever your local BASF rep is.
Okay.
BASF's stone wool based system is called Vulcan, like Mr. Spock. Or the volcano god. But as I said, it's being used in Europe. It's being used in Canada right now. It's a relatively simplified system in Canada. I suspect once it really gets market traction here, it'll probably be a little more complicated. It'll use some more drainage plane components, what have you. But it might be a good starting point just to have a look at it and know what your options are. And if you're truly a year out, then you might well be in, you might well fall into the timeline.
Yeah. Okay, I'll check it out. Thanks,
Rob. We got time for a few more questions. We could fit a few people in. Does anyone else have any questions they'd like to ask? I'm not seeing any hands in the air. We did record this session. We did not record the first session, but we did record these, and Jim will post that recording probably on our website, and we'll send out an email to everyone so they can have a copy of it. We'll also put this deck with that, so you'll have it out there. And as I stated before, Rob and Mike are available for a lunch and learn. They have a longer version of this. I think it's closer to an hour presentation. And they're also and they're also happy to share that deck as well. So I would recommend strongly that you take advantage of the resource. It's an incredible resource that they both provide for our community, and appreciate it very much. Jim, any questions we missed on your end?
No, I don't have any questions from other folks.
I thought you were going to drill them, man. I was waiting for it.
I always got my own questions. But...
All right. Well, with that said, we are at the top of the hour. We went over a little bit. I respect everybody's time, so thank you for coming. Let me switch screens here real quick, Rob, if you don't mind.
Yep.
And I will do... Can everyone see my screen?
Yep.
Yes.
All right, Jim, you're up.
So here's a schedule for the next events, the next 4 events, as we cover the 5 Passive House principles, right? Today we did installation. Next time we're doing thermal bridge free. Maybe a little bit of some of the design, some of how it's done. If you are not currently getting our newsletter and want to find out more about how to sign up for these events, because each one you need a different sign up for it, for a registration for a Zoom link. You can go to our website. You can go to info@passhousebuskerpa.com. You can try and find us on Instagram. Any way you can get a hold of us, we'll put you on the mailing list. We'll send out an invite sometime in the next week, because that next one is in 2 weeks from today.
2 weeks. And we also want to make an announcement. We have Matt Bowers, who's going to be our expert presenter at the Thermal Bridge Free Connection. Matt is a Passive House Institute certifier. He's also CPHD, and he does the thermal bridge analysis for PHI through, I think he's doing all Stephen Winter's thermal bridge analysis at this point. So he's a great resource. You want to hear from him. We're going to be opening up the program and showing examples. So it's not going to be so much of a technical overview of what is a thermal bridge. We're actually going to get into it and show you guys how to model it. So roll your sleeves up for that one. You're going to need it. And then from there, that was our last slide. So everyone, thank you very much for joining us. Rob and Mike, thank you for joining us today. Appreciate it.
Thanks so much for having us. We really appreciate it. I'm looking forward to seeing you all in person again when life returns to normal, and then Jim can drill me with questions over beers.
Yeah,
He will.
Sounds like a plan.
best way.
All right, everyone, have a great evening. Thanks again.
Have a great night all.
Thank you, guys.
Bye-bye.